In this video, we're going to learn how to use Descartes' rule of signs to narrow down between the positive and negative real zeros. So if we're doing the rational zero theorem and we want to know are there any more positives or any more negatives, we can use Descartes' rule of signs to help determine that. Descartes noticed that if a polynomial with real coefficients, then the number of positive real zeros is less than or equal to, by an even real number, to the number of sign changes of the given function, f of x. And the number of negative real zeros is less than or equal to, by an even number, to the number of sign changes in f of negative x. So we're going to use Descartes' rule to determine the maximum possible number of positive and negative real zeros for this function. So we're given the function f of x equals 2x to the fourth minus 10 plus 11x squared minus 15x plus 12. So we're going to be looking at the number of sign changes to fill out this table. Notice what we're talking about sign changes, that the 2 is positive, the 10 is negative, the 11 is positive, the 15 is negative, and the 12 is positive. So as this polynomial changes from positive to negative, that is one sign change. Negative to positive, that's 2 sign changes. Positive to negative, that's 3 sign changes, and negative to positive, that's 4 sign changes. So this polynomial has a maximum of, or a possibility of, 4 positive zeros. Or it could be less than that by an even number. So there could also be 2 or 0. It is a 4th degree polynomial, so there is at max 4 zeros. That's from the fundamental theorem of calculus. Now, let's determine how many possible negative zeros there are. F of negative x, if we replace all the x's with negative x, so the negative x to the fourth minus 10 times negative x cubed plus 11 times negative x squared minus 15 times negative x plus 12. Let's simplify this. At the even power, the negative goes away, so it's just 2x to the fourth. And then an odd power that will stay negative, combine with that negative, make a positive 10x cubed. This negative squared will be positive 11x squared. Negative times negative is positive 15x plus 12. Positive, 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 positive. There are 0 negative roots. And less than that by an even number, still 0. 2 minus 0, or 0 minus 2 is negative. We can't have a negative number of roots. So 0. So there could also be some complex roots. Say that we found, if there are 4 positive real roots and no negatives, then there would also have to be no complex, because our total has to always equal 4. But if there are 2 positive and no negative, that would leave 2 that must be complex. So 2 plus 2 is 4. These have to always add to 4. And if there was 0 positive and 0 negative, that would mean there'd have to be 4 complex zeros. And that would add up to 4. So these are the possibilities. There's either 2 positive and 2 complex, or 4 positive and 0 complex, or 0 positive and 4 complex. But if we were using the rational zero theorem, then we would waste our time testing the negative answers. And we could find that out by plugging f of negative x and seeing that there are no sign changes in f of negative x. So let's do another one. Find the possible zeros of this polynomial. The polynomial is x to the fourth plus 2x cubed minus 12x squared plus 14x minus 5. Alright, so let's look at the sign changes here. Positive, positive, negative, there's one sign change. Negative to positive, there's another sign change on positive, negative. There are 3 sign changes on this one. So let's make our little table again. Okay, so we had 3 sign changes in f of x. So there's possible 3 complex zeros, or less than that by an even number. So 3 minus 2 is 1. Alright, so there is definitely 1 or 3. And then to look at the number of negative zeros that there might be, we could look at f of negative x. If it's even, it's going to stay the same, and if it's odd powered, it's going to be the opposite. So x to the fourth will stay the same. 2x cubed will be the opposite. So it was positive, so now it's going to be negative. This is going to be the same. This is going to be the opposite. And the constant will not be affected. Okay. And you could double check that by replacing all the x's with negative x and simplifying. But again, shortcut, if it's even powered, it's going to stay the same. If it's odd powered, it's going to become the opposite. Now let's see how many sign changes there are. Positive to negative, that's 1. Negative, 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 negative. There is only 1. So there is 1. Okay. So this tells us it's a 4th degree polynomial. If there's 3 positive and 1 negative, then there would be 0 complex because it has to add up to 4. There's less than this by an even number. That 0 isn't less than this by an even number. And we can't have 3 complex zeros. They always come in pairs. So this has to be the situation here. There has to be 3 positive, 1 negative, and 0 complex solutions. So that means if you find that negative solution, there won't be any other negatives. But it's probably best to search the positives because most of the zeros are going to be in the positive values. Okay, so let's look at some word problems. This is word problems from the OpenStax book. It's a free online book, page 413, number 72. The length, width, and height are consecutive whole numbers, and the volume is 120 cubic centimeters. Find the dimensions of the box. Okay. So, page 413, number 72. Length, width, and height are consecutive whole numbers. That means if this one is x, then one of them is x plus 1 and another is x plus 2. They tell us the volume is 120. So we need to solve this cubic function. To solve a polynomial, let's get everything on one side. So I'm going to multiply this out. I'm going to multiply these. X squared plus 2x plus 1x plus 2 equals 120. And now I'm going to distribute, I'll move this up a little, distribute the x and combine these terms at the same time. 120 equals x cubed plus 3x squared. 1x plus 2x is 3x, and then I'm multiplying by that x. And then plus 2x. I'm going to get everything on one side. X cubed plus 3x squared plus 2x minus 120. That's my function. Alright, now I see that positive, 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 positive. There's only one sign change in f of x. So there is only one positive solution. Which we were, hopefully, if you've got links of the side of a box, you would expect there to be a positive solution. And if we looked at f of negative x, this one would be negative, positive, that's not going to change. This one's going to become the opposite, and this one is going to be unaffected. So there are going to be two sign changes there. So there's one positive, two negative. So since there's three total, it's a third degree polynomial. We know there are 0 complex solutions for a total of 3. Alright, so there's 2 negative solutions and 1 positive solution. Now, I only want the positive solution. I only want my links to be positive. So I'm going to search for the positive solutions. Well, the rational zero theorem says take 120 over 1, and take all those factors. There are a lot of factors of 120. Like 1, 2, 3, 4, 6, 12, 10, actually I skipped 10. 10 is a factor as well, and so is 5. 5, 10. And if I were to, let's kind of think of these up here. 10 times 11, that's already too big. So I could try these in here and see which of these make 120. 4 times 5 times 6. Alright, so I think it's going to be in this zone. So I'm going to use synthetic division to check it. Alright, so I've got 1, 3, 2, negative 120. I'm going to try 6. 6 seems like it might be about right, and it wouldn't be that hard to get out of the calculator. Go 6 times 7 is 42, 42 times 8. Doesn't seem quite right. 1 times 6 is 6, plus 3 is 9. 9 times 6 is 54. 54 plus is 56. 6 times 56, that's too high. 6 times 56 is 336. Not a remainder of 0, not a solution. Alright, I'm going to try the 4. What if I have, moving up, moving on up, okay. 1, 3, 2, negative 120, and I'm checking to see if 4 is a 0. 1 times 4 is 4, plus 3 is 7, 28, 30. Oh, this looks really good. 4 times 30 is 120. Remainder of 0. There we go. We found our one answer. It's the only positive answer. And we can double check that it is a solution. 4 times 5. 4 plus 1 is 5. So that's 20. And 4 plus 2 is 6. 20 times 6 is 120. This is our solution. So we solved that using what we've learned with rational zeros, and we narrowed it down a little bit using our tools for the trade. The next one is number 74 from the OpenStax book on page 413 in section 5.5, polynomial and rational functions. The length is 3 times the height, and the height is 1 inch less than the width. The volume is 108 cubic inches. Volume is 108 inches cubed. Volume is length times width times height. And they tell us the length is 3 times the height. Length is 3 height. They tell us that length is 3 times the height. The height is 1 inch less than the width. The height is the width minus 1. The volume is 108. So what we need is all these in terms of one letter. We don't need 3 different letters. So how can we get these all in one letter? Well, if I take this length and see, if I take this width equals the height plus 1. So there's the width in terms of the height, here's the length in terms of the height, and then the height is already in terms of the height. So now I've got them all in terms of the height. Okay, so the volume is length, 3h, times width, h plus 1, times the height, which is just h. We also know that that's equal to 108. I'm going to distribute this. Let's see. This is 3h squared. Now I'll take that times h plus 1 and multiply to each of those. So 3h cubed plus 3h squared equals 108. Wow. Do we really want to, oh yeah, we need to unfactor that because we don't have this side equal to 0. We really can't solve this without it equal to 0. So I'm going to move that 108 to the other side, making it 0. I'll call this a v of x instead of f of x, a v of x, because it's my volume function. Okay, so here we have this. Now, if we apply Descartes' rule and we look at the positive sign changes, we could see, again, we really only want the positive solutions. There is only one sign change, so there's only one positive solution. And honestly, if I change this to negative, that would be negative, positive, negative. There would be 2 sign changes. But again, for volume, I probably don't want those 2 negative solutions. But there are 0 complex solutions. It's a 3rd degree. Alright, so there's one positive solution. We can use the factors of 108 to find those solutions. So factors of 108. Let's see, 108 is 2 times 54. 54 is 9 times 6, so 2 and 3 and 3 and 3. So our factors are going to be combinations of those numbers. So 2 plus or minus 2, comma, plus or minus 3, comma, plus or minus 6, plus or minus 9. I wonder if that's high enough. 9 times 3 is 27. 27 times, yeah, that's way too high. It's not going to be higher than that, just looking at the problem. So even 9 is too high. And I don't really need the negatives. So 2, 3, or 6. Or I have to also consider that this could be a fraction. I have to consider, and again I'm throwing out the negatives because it's a volume problem, but 6/3, that's 2, 3/3 is 1, 2/3, what about 9/3? That's 3, so there's nothing new there. 2/3, I would think that would be kind of low, too low to work, so I'm not going to definitely try it first. I think 3 or 6 is a good try. So here's my polynomial. 3, 3, 3, 2. Notice there's no H term. So if I could plug in 3 here and see if I got f of 3 was 0. Or you can plug it in here and see if you're getting 108. But if we do this stack 3, I think 3 is going to be a little low. Drop the 3. 3 times 3 is 9. Add 9 plus 3 is 12. 36. 36 times 3. That's got to be close to 108. 90 plus 18, that is 108. 3 did work. So 3 is our solution. We were able to narrow down to that pretty quick. So the height is 3. The question was find the length, height, and the volume. I didn't even ask a question. I said the length is 3 times the height, and the height is 1 inch less than the width. The volume is 108 cubes. Find the dimensions. Okay, so the height is 3. The height is 3, and the length is 3 times the height. If we recall up here, the length is 3 times the height. So the length is 9 inches. And the width is the height plus 1. So that's 4 plus 1. 3 plus 1, which is 4 inches. So there we have that one. Yay! Alright, and another example of word problems. This is number 78 in the book. The radius and height differ by 1 meter. The radius, let me read the instructions over that. For the following exercises, find the dimensions of a right circular cylinder. Okay, so a cylinder. So a cylinder, I'm going to draw a little picture. There's our cylinder. Okay. The radius and height differ by 1 meter. So if this is x, then this could be 1 different, x minus 1. The radius is larger. Good thing I put that x minus 1 here, otherwise I would have to switch it. The right here, if this is x, this is 1 meter less. And the volume is 48 pi. The volume equals 48 pi. The volume of a cylinder is the area of a circle times the height. So it's pi r squared times h. I'm going to replace the r and the h with x's and x minus 1. So the volume equals pi times r squared, that's x squared in this case, and x minus 1. I'm going to replace the v with 48 pi, which is nice because that's going to cancel out. So the pi's cancel. So I have 48, because if I divide both sides by pi, it will go away. Anytime you want to solve a higher power, you have to get it equal to 0. So our volume function is equal to x cubed minus x squared minus 48. Again, I'm really only interested in positive solutions because I don't really want a negative radius or a negative height. Those won't make sense for this problem. And I'm going to be looking at factors of 48 divided by 1, so 48. 48 is 2 times 24. 24 is 2 times 12, and 12 is 3 times 4. 4 is 2 times 2. So we're looking at 2, 3, 4. 2 times 3 makes 6. 2 times 4 is 8. And I bet 8 might be as high as I need to go. 8 squared is 64. 8's way too big. Alright, so we're probably looking down here, 2, 3, or 4. Let's try 3. Let's see if 3 is a 0. 1, negative 1, 1, negative 1, 0, because there's no x term, 48. Now I'm going to see if 3 is a 0. 1 times 3 is 3, add 2, 6. Nope, 3 is not big enough. So try 4. Why? I'll go ahead and show you. Look, 3 times 6 is 18. It's not reaching the negative 48. So I'm going to go up to 4. 4. And maybe I'll use... Oh, I did that. All that off screen. Okay. I'll redo that for you. So here I wrote the coefficients. 1, 0, negative 48. 1, negative 1, 0, and negative 48. And I'm trying to see if 3 will have a remainder of 0, and it didn't. So now I'm going to try to see if 4 will have a remainder of 0. 1, negative 1, 0, negative 48. I think this looks really promising, I think. 1 times 4 is 4, and that adds up to 3. 12, add is 12. 4 times 12 is 48. So 4 is a solution. Yay! So we know that the radius is 4 because x was the radius. So the radius is 4, and if the radius is 4, then the height was 1 less than that. So the height is 3. So again, going back to the problem, x was our radius, the height was x minus 1, so we have a radius of 4 and a height of 3. And those are application problems of the rational zero theorem. It helped us narrow down the solution. Again, we were only looking at positive solutions because these real life examples where negative answers didn't make sense, so we didn't have to check out the negative possibilities. And then just looking at the reasonable of the answers, even though 48 has lots of factors, and I'm looking at multiplying these numbers to make 48, I knew that I couldn't be multiplying like 8 times 7, or I needed smaller numbers, so we could really narrow that down quickly. So the rational zero theorem, Descartes' rule, complex conjugate theorem, they help you narrow down the answer and get it a little quicker. Let me know if you have more questions. Contact me. Write any comments below, and I'll try to get back to you as soon as possible. I'm here to help you.